The next thing we're going to cover in this lesson is increasing, decreasing, and constant functions, and specifically where they are increasing, decreasing, and constant. So a function is increasing when it rises from left to right. And so you can see in this diagram here, you have an increasing portion here because as it goes from left to right, it's increasing. And here, as it goes from left to right, it's increasing or it's rising. The technical definition is as your x values are getting bigger, your y values are also getting bigger. You can see here as you're going from -4 to about 2, that y value is increasing quite rapidly here. Same thing here. As you're going from 2 to 4, that y is increasing almost just as quickly as the other increasing. Decreasing is when it falls from left to right. So here is your decreasing and it's going down right there. Or again, that technical term is as your x values are increasing, that your y values are decreasing. So you can see from -2 to 2, that y value is going from -16 and going down to -16, from +16 to -16. And then your constant functions are your horizontal line. I don't have a picture of that here, but when it is a straight horizontal line, that is your constant. Okay. So we can see from the diagram, increasing and decreasing. We kind of have a general idea. So example 2, use the graph to find the intervals on which the function is increasing, decreasing, or constant. When we are stating these, we want to use our x values and we will use parentheses. We're using x values and we're using parentheses. So where is this graph increasing? I'm going to give you a minute to find that section. And hopefully you kind of said in this little section right here. In that little section, as it's going from left to right, it is rising and those y values are getting bigger. So it is increasing from -4 to 0. And we are using parentheses. X values, parentheses. Okay, so now where is this decreasing? I'm going to give you a minute to find it. How many intervals do we have decreasing? Hopefully you said 2 and we're able to find these 2. So as you're going from left to right, these are falling and their y values are getting smaller. So this one is from -6 to -4 because we're looking at those x values here. And then this one is from 3 to 6. I don't need the union there. Okay, so then that leaves my unhighlighted part to be constant, so I might as well highlight it. And it is constant, that horizontal line from 0 to 3. Okay, so let's put that first page and this to kind of together on example 3. Use the graph to find whether the function is even, odd, or neither. Okay. From that first page here, we said that even functions have y-axis symmetry, while O for odd has origin symmetry. I'm going to kind of write under here, this is y-axis, and this one here is origin. So, does it have y-axis symmetry? It doesn't look the same on the left, on the right as a mirror image. And yes, it swoops down, it swoops down. If you fold that on top of each other, everything is going to land right on top. So this one has even. is an even function. And you can see if you rotate that, now this is opening up, which it was opening down. Okay, intercepts. Hopefully you have practiced these or you already are good at these. These frustrate me, if I'm being honest, because they are very, very simple and we miss them like crazy and I don't understand it. Intercepts. Where is it crossing the X and Y axis? So here's my X axis. Where is this crossing my X axis? Right here at negative pi, comma 2, or sorry, negative pi over 2, comma 0. And right here at pi over 2, 0. Then my y-intercepts is where it's crossing the y-axis, and that is right here. 0, 1. Even though they give you this, these are not intercepts. They are doing this to show you this even, right? So say opposite inputs give you the same outputs. And also remember to put commas in my map book. All right, domain and range. This was from last lesson. As you go from the left to the right, your leftmost x value is right here at negative pi. And as you keep going, it's all the way to pi. Your range, as we go from the bottom to the top, your lowest y value is right here at negative 1. And your highest y value is at 1. Okay, and now part D, the intervals on which the function is increasing, decreasing, or constant. So increasing is from where to where. Increasing is right here, and we are going from negative pi to 0. With these, we use parentheses. Okay. And I probably should have explained it here. Let's just go back up here. I'm using parentheses everywhere. Notice parentheses at both of these zeros. Because at this 0 here, where it's changing from increasing to now constant, I can't really say at 0 it is increasing or constant. At 3, we have parentheses because I cannot say at 3 that it is constant or decreasing. It's changing directions. I can't say here at negative 4 that it is increasing or decreasing because it's changing directions right there. So where it changes directions, I'm not saying it's increasing or decreasing. So same thing here. It's changing directions from increasing to decreasing. So I cannot put it in one of those categories between increasing and decreasing. And so I'm going to use parentheses. I also don't know what's happening beyond that negative pi. It is possible, and really it's not, because this is a cosine graph, so it's going to curve back up. But technically, if we didn't know that, it could keep decreasing, but keep increasing by going down. But I don't know that, and in fact, it's going to end up turning up, so I can't say at these endpoints whether it's increasing or decreasing either. Okay, so now decreasing, I've already highlighted that. That's in green. That is from 0 to pi. And we just discussed where it changes directions. I cannot say what's happening in that endpoint. I cannot say what's happening. And then lastly, constant. And this one has no horizontal lines. So this one is at